I guess I'll ask the panel about launch, but that's a separate issue. Um, Weather, adverse weather, icing, thunderstorms, lightning, garbage weather, basically. How does that fit into that NASA constrained flight test? Are you inputting adverse weather, and how does that fit into the design and the operational feasibility? I was thinking in the DC area, I go out in the morning, I do my business, and I walk out to the heliport or vertiport, and now we got a thunderstorm like yesterday in progress. Am I stuck there? Or do I have to rent a car or take Uber back? What do I do? So what's the envision for this urban air mobility system?
Yeah, so and that use case is one that we've discussed several times, where if we start counting on the urban air mobility as your choice of transport and the weather conditions change, do we have a mechanism for how we get you back to where you need to go? And for the Grand Challenge, we are essentially taking weather for the initial Grand Challenge. That is to be determined later. Part of it is for safety concerns, safety of the test conditions and of the pilot, and it's remotely piloted, people on the ground. Some of these aircraft systems are ones that are prototypes, and we are trying to understand first how they fly in nominal conditions before we get into some of the more challenging icing or lightning types or storm types of conditions. Another is just feasibility in terms of the Grand Challenge flight testing. We have limited time that we'll have to spend with each of the participants. We're looking at a good 6 weeks, depending on the number of participants. If we have the number that we estimated, which would be approximately up to 6 for the initial Grand Challenge, we could spend up to 4 to 6 weeks with each, and some of that is where they're flying. It may be difficult for us to at least enforce a type of weather condition. That's not to say if we try to do something in the winter at one of the more northern locations, we couldn't implement that, but what we need to do is then back it up into industry and say, what is the business case? Right now, my understanding is most of the business cases are in more fair weather types of cities. When we get into cities that have a significant amount of overcast, cloud cover days, that's not one of the ones that they want to or choose to go to first. And so I think what we're looking to do in terms of, on the NASA side, is understand nominal operations and get a good sense of nominal operations before we then look at, from a research point of view and from a demonstration point of view, how do we do something that's a little bit more difficult.
No, and you bring up a very good point. I heard somebody say the other day about urban air mobility, all-weather capability. I'm kind of laughed. I said, there's no such thing. But I kept my mouth shut. Now, in looking at that, we are working with a group. It's several groups, actually, but one of the ones that's taking the lead on is National Center of Atmospheric Research out of Boulder, working with Matthias Steiner's group out there. And if you've ever heard of it, you'll hear the term FPAW, Friends and Partners of Aviation Weather, which is under NBAA. So in next NBAA in Las Vegas, I believe October, we actually have a half-day panel discussion on urban air mobility weather. And we're looking at turbulence and winds. Also, one of the other ones in the northern latitudes are icing. And so far I've seen certain UAS drone vehicles do not do well with icing whatsoever. So it's one of those situations where we're working on that panel discussion right now. So if you happen to be at NBAA, look for that. Definitely invite anybody to come to that. But that's in-car, FAA, got several different folks from NOAA and Aviation Weather Center involved, and some others. Great people working with that.
My question is probably mainly for Rex. It's concerning heliport, vertiport location, and I guess I'm trying to reconcile what I see in the world in terms of where they've been successful in developing public use heliports, and then the vision that the urban air mobility organizations have in terms of what the optimum location is. What I've observed is in a lot of cities, particularly where I'm from in Vancouver or the West Coast, the waterfront heliports and the floating heliports have been the ones that have gone into place and near the downtown cores and have achieved high utilization. And if I look at New York City, whether it's 34th Street, 30th, or Wall Street, I also see waterfront heliports. And yet most of the artist conceptions and plans that have been produced are showing heliports within the urban canyon or inland. And I'm trying to reconcile what I've seen in terms of what people have actually physically been able to do, waterfront with clear approaches versus something that's a little bit more urban. And I'm trying to understand from either from a pilot's perspective or a planning perspective or an approach perspective, what are we likely to see first? Is it actually going to be in the urban canyon, or is it going to be... I open it up and say, what do you think?
One of the challenges you run into in this particular environment, there's a lot of heliports out there that exist today that just aren't a good business model. And a lot of them were never meant to be good business models. So as I talk about the air medical world, they're only going to service one particular client, one particular customer. Whether they get used or not doesn't matter to them. Now, when you look at the public use facilities out there, so the ones in New York, they have a business model. They have a criteria that they're trying to meet to generate throughput, which then generates revenue. There's not that many in the United States that have been that successful. Most of them have had to have multiple different lines of business to generate enough revenue to stay afloat. There's a lot of them out there. The Indianapolis Downhill Heliport has like several different lines of business operating there. They sell office space. They put on different things to make enough money to keep it afloat. For the longest time, it was a white elephant that was basically around the city's neck. Then the Airport Authority of Indianapolis took it over. There are some out there that are marginally successful, but not to the vision that Uber has. And a lot of it is how much throughput you can put in there. Not that many people show up at these things. And that's the only way you're going to have that kind of revenue, is having that landing fee constantly coming in and going out. And those other, and a lot of, if you look at the designs that a lot of people come up with, there's other things there. It's more of a destination because they have shopping, they have other things. Now, to your point, where do you put this? That becomes the fun part, because as we said, there's a standard across the US, which is the FAA standard. But when you get to the state level, there's basically 50 different ways of doing business. In there is where our company makes probably its most money, is trying to figure that out. Then you go down to the next level, you get to the local level, you have the municipality. So in Chicago, you have the state standard, then you have the FAA standard. Then you go below that, you have the county standard, and then you have the city standard. And you have to go through all of those layers, and that can be a minefield in trying to figure out where you can and can't do business. So it may be a perfect location from a aviation standpoint, but you can't get it zoned. It may be zoned and it works great, but from an aviation standpoint, it makes no sense whatsoever. So you get into all these different discussions. It's like Reason's safety Swiss cheese model. What we're trying to do is line up 15 different layers of Swiss cheese and find that one spot that goes all the way through all those different arguments that makes the case that that's a good location. And you're playing, when I worked with Uber, I said it's easier to say where it can't work versus where it can work to start, because you can take a lot of stuff off the table fast, and then what you got left over, work from there. The water-based heliport, in my mind, works really good. We've done several of those. We just finished one up in Miami 2 years ago. Clear airspace, not going to disturb the neighbors too much. As long as it's not a waterway where you have active shipping, you're good to go. There are some challenges there. I won't get into that, but getting good approach departure paths, taking into account the winds, taking into account the neighborhood, taking out the zoning, that does work well. Now, if you can get the throughput you need, then the business model works well. But a lot of them I've seen put in end up being barges that get towed away a couple years later because nobody uses it. So.
So this is another one where taking a look at the artist rendering, and Uber had one of the concepts they have is for ride sharing. And so instead of just ride sharing on the ground, have a flight component to it. It's one of their Uber Elevate. That's one of the cornerstones of Uber Elevate. And so when they're looking at locations for vertiports, it is somewhere where they can take you that last mile. And that's the critical part of whether this is going to be used as a mechanism for transportation. Do you need to have a last mile concept to it? And if you need the last mile concept, then it's how do you get to that last mile? For the helicopter, in New York City, where they have some helicopter operations there, they're taking you to the airport. So you don't have that last mile. The destination is that last mile. And then they have the infrastructure within New York City to get you to the waterfront. And so they have the first mile is also taken care of. But for this to be done at a more generic city, and it's used depending on its use case, if it's to get in and out of, let's say, a sporting event, then if you have the vertipad close to whatever arena or stadium, the last mile is taken care of, and that's a use case that may make sense for throughput on certain number of days a year. And so the use case, the business case is really important whether this is going to be feasible economically long term. And if we don't take care of all of it, which is not just the flight portion of it, but that last mile and all of it together and take it into consideration altogether, it's something that, you'll build the barge, and then 2 years later, it's not feasible and can't be used, including on top of buildings where the concept is we're trying to save time. So you'll see savings of time versus driving or versus ride sharing. And if you put your vertipad location on top of a building, you've just shifted the time it takes the bottleneck from the ground into the elevator. If it's on buildings too high, elevators are slow. They take a long time, and there's a queue there. And so that only benefits the people working inside that building, and your throughput might not be what you expect. So it's interesting.
Sure.
Yeah, what I see in Vancouver, Nanaimo, Victoria, where there is scheduled helicopter service, and there has been for 30-odd years, I guess there's already a propensity to go to the waterfront to fly because of the seaplane service, and I suppose in Seattle as well. And so maybe that's the intermediate step. But from a fly neighborly point of view, it seems to work very well in terms of the approach paths in each of those locations, such that the traffic has grown over the years. But I'm wondering from a regulatory point of view, if you put something on the water as opposed to on the land, can you duck some of the zoning issues? Maybe that's kind of an abrupt way of putting it, but.
You trade one for another sometimes. It depends on where that water is, who's got the easement to that water. We did the one in New York, a feasibility study, and when you looked at where that water was, all of a sudden it was like, well, that was in the jurisdiction of the Coast Guard, and then you had to deal with them. Now, the key there is on a floating system, there's no standards out there that speak to floating systems per se. If it's a fixed system, so you work in the oil industry, if it's fixed versus movable, two totally different animals. So we get into shipping, and it's like, well, if it's something that can move, well, there's no standards in the U.S. for that. If you look at all the helicopters that land on ships today, most of those ships, if not all, are actually certified in the U.K. Most of those ships that have heliports don't have a certification in the U.S. Now, the U.K. actually has standards for that. When you look at the piece on the political side, it can be fun. If they say, hey, you're killing some snail darters because you're flying in and out of there, you're hosed. Because there's the EPA piece for fuel also. If you have fuel on a barge, that's a big deal. And how are you going to protect that? How you can keep from spill? That's where the electric piece makes much more sense, much more friendly. One of the issues we run into, we've had this discussion quite a bit, is what's the timeline? And that's the viability of investors. So right now, I'm working projects across the country. It takes about a year before I submit for an airspace study, before I actually get the FAA to come out and do the airspace study and give me an airspace determination. I have to have that to go to local municipality, because without that, they won't give me a conditional use permit, and the guys over at the fire department won't talk to me to give me my certificate from fire code. So it's, right now it's very linear. Add into this the electrification piece. If you have to bring power to you, is that area that you want to put that boat, is there power available for a charging system? Or do I have to bring power in? If I have to bring power in, all of a sudden a $4 million project just went to 10 because it's expensive to bring power in. And when you start talking about the power we're looking for rapid recharging, and you start getting up to the 5-6 megawatts, now you got to build a substation. Substations take about 2 years to get permitted, then it takes about 2 years to build. If I add a year on the front and a year on the back, no investor is going to touch that with a 10-foot pole. So that's one of those issues we run into. Where am I making my money? It's just sitting there. So squeezing that down and shortening that timeline and then taking those things that are linear and overlapping them, that's kind of the magic sauce we're looking at right now.
Dumb question and potentially quick question. With this eVTOL, does the computerization allow for a smoother ride, both for the passenger as well as during that approach where you had the rotating wind, updrafts, downdrafts? Can the computer compensate both in the en route phase and in the approach phase and make it smoother for the passenger?
I'm probably not the best person to answer that, but in my mind, I say it probably will be because the reaction time for pilots is based on their experience level
Yeah, us.
and their knowledge of that location. If you get a low-time individual going into a place he's never been before, his ability to react and anticipate will be totally different from a high-time pilot who's been in and out of there many, many times. So you take that out of the equation by probably making this an autonomous vehicle that's sensing constantly what's going on. Now, one of the cool things I saw recently when it comes to winds and turbulence that's in development is using LiDAR to actually map turbulent zones in urban areas. It can actually sense and tell you where that air is going, how fast it's going, where to avoid, where the best area is to go through. If you can do that and then tie that into real time to that computer, it would be amazing what you could probably accomplish.
If-
It's called active blade control.
A man smarter than me.
Is that a viable?
I'm going to interrupt because we are running late, and I want to get everybody to lunch. Go ahead and go ahead.
Just say all the presentations were great. Thank you. Just to maybe help Peter out a little bit, I saw your presentation title implementing.
Hold on a sec. Let's get.
Great. Yeah, all of your presentations were great. Thank you for that. I just wanted to make a comment to Peter and to follow on to your discussion. Maybe this will help you. Your title said implementing autonomy from a safety assurance perspective, and I was hoping you were going to say SAE S18 committee in your presentation because that's exactly what they're looking at right now. You even had the control loop rings, the inner loops and the outer loops as they go on, as they go out, and that's exactly what some of the drawings I've seen discussed at the committee. So I was wondering, are you engaged with that committee by any chance? And if you're, and you told me before that you're heading out on Wednesday. If you get to Portland on Thursday, you could get into that discussion. If you're heading back to the West Coast.
Well, I wish I could. I haven't had any interactions with SAE or with that committee on this topic. But yeah, I mean, it makes sense to try and frame it that way when we're really broadening the community of people that are participating in this discussion around how we design a system with safety assurance in mind. And to walk into this set of issues and all of the different programs that are being pursued is a very steep learning curve, because every program has its own particular details and its own implementation timeline. And the way that I arrived at thinking about it in terms of those slides that I created was to try and look at all of that and then step back and say, okay, well, if you were just coming up this learning curve, what would be the foundational concepts that you'd want to first absorb? And then you can hang all of these other details and programs and timelines onto that, and then have a more unified understanding of what is the path ahead, where do we sit today, and what are reasonable expectations for seeing different levels of autonomy in an aircraft or in the airspace system. So it's cool that we kind of arrived at similar points.
Right. That's quite amazing, and especially when you prefaced it with, I just came into this 3 years ago and started thinking about this. So it sounds like you're on the right track, so I applaud you for that, and I think we should make that connection there.
Cool, thank you. We
Sure.
should connect in more detail then directly on it.
Sure, thank you.
Thank you. Okay, I'm going to cut everybody off. I'm also going to give you only half an hour for lunch because we've got to get back on schedule. So 1:45, we're back in here. Lunch is out in the Great Hall. All right, thank you. Please thank these presenters.